Algebra 2, solving equations by graphing and square roots. This is Concept 9 Teacher Talk. Let's hit the highlights on this concept. So, we're going to draw quadratics with the following solutions. So, a solution of a quadratic is where it crosses the x-axis. So, in number 1, we're going to have points right on the x-axis at 2, 0 and negative 3, 0. So, a parabola that would have those solutions would either cross through and open up, or I could have drawn one that crossed through and opened downward. So where it crosses the x-axis, the highest or lowest point of that parabola will be between, right in the middle of those 2 points. Now sometimes your quadratic parabola will just touch down on the x-axis at one point. That means the solution is the vertex. So here's an example of a parabola that opens down that has a solution at negative 1, 0. See how its vertex is right there? Because that's the very highest point of this parabola. Sometimes you'll have quadratic parabolas that have no real solutions. That means that there's no way they could ever touch the x-axis. So they will be up in the upper quadrants opening upward, or in the lower quadrants opening downward. Now let's solve each of these quadratics. Notice on number 4 we just have an x squared term, so that means we can isolate it and take the square root. So subtract 9 and then divide by 3. So x squared equals negative 3. Now this is an example of where an imaginary number will show up, because the square root of negative 3, think of it as the square root of negative 1, which is I, and then the square root of 3. And then always remember, with your square root solutions, you need to give the positive and negative case. On number 5, let's do the same thing. Let's isolate the x squared. So add 13 and divide by 4. Now, we need to take the square root of 62/4. When we take the square root of a fraction, we're going to keep it in fraction form, because we can take the square root of the numerator and denominator separately. And in this case, it helps us out, because the square root of 62 is just that, positive and negative square root of 62. But the square root of 4 is 2. So our answers here are positive square root of 62 over 2 and negative square root of 62 over 2. Let's do just some operations with the I term, the imaginary unit. So remember that the imaginary unit is the same thing as the square root of negative 1, and then I squared is the same thing as negative 1. So we always replace I squared in our problems with negative 1 to simplify. So here we are multiplying those two binomials together. So I'm going to use the box method. So I have 2 and 3i across the top and I and negative 8 across the side. So I get 2i, 3i squared, negative 16, and negative 24. Should be an I there. There we go. So now I'm just going to write them horizontally, and then I'm going to combine my I terms and then replace my I squared with negative 1. So I get negative 3 minus 16, which is negative 19, minus 22i. And this is the form that you want to write these answers in, these complex numbers in. So the real number part goes first, and the imaginary part goes second. Now notice in number 7, it looks like we're multiplying, but actually there's a subtraction in between those. And I notice that 21 and 9 can be simplified to 30. I'll distribute the negative and then just combine my real numbers. And when we write it in what's called standard form, with the real number part first and then the imaginary part. All right, that's a quick just highlight and review of solving by square roots and using the imaginary unit, complex numbers.